Hello everyone, I am Sai Ganesh, Assistant Professor. Today I am going to explain the continuation topic of integration. In this section, we have to learn some more shortcuts regarding the integration concept. Now see, suppose that is the method 4. In part 1, we learn 3 different methods. Now coming to the part 2, we have to learn some more methods. So coming to the method 4, suppose the integration is in the form of integral x power n f of x dx. Here this integration contains the two different terms, that is the x power n term and f of x term. So here n is the constant and that value is 1, 2, 3 and so on. Now here f of x is the function. The f of x function is any function, either trigonometric function, logarithmic function or exponential function. F of x is a function. So here the x power n term is product with the f of x. Suppose the given problem is in the form, that is integral x power n f of x dx. Now we have to get the result of this problem by knowing the shortcut way very easily. So to solve this problem, we have to do the two operations, that is the differentiation operation and integration operation. Here these are the two different terms, that is x power n and f of x. First of all, we have to write the x power n as usual, that is the x power n. Now we have to do the differentiation for this x power n, that becomes the second term. So we know that differentiation of x power n becomes n into x power n minus 1. So this is the first term and this is the second term. We are performing the differentiation here. So now we have to get the another term, that is the third term. So how to get the third term? Again we have to differentiate this second term, we get the third term. So that is the third term, that is new term. Again we have to differentiate the third term to get the fourth term, that is the another new term. So this differentiation process is continued till we get the 0 as the last. So definitely we get the 0 because of already we told that so n is a constant, either 1, 2, 3. So here constant means finally we get the 0 as the result of the differentiation. So this process is continued till we get the 0 as the last one. So simply we can performing the differentiation for the x power n term. Now we have to perform the integration for this function f of x. So first of all, the first term is obtained by integration of f of x. So integration of f of x, that is the first term. Now we have to get the second term by integrating this first term. So that is integral of f of x. So the third term is again we have to get the third term by integrating this second term. So we get the new term, that is our third term. So this process is continued to the number of terms. That number of terms is equal to the number of terms in the differentiation. Suppose the differentiation having the 4 terms. So this process is continued for only for the 4 terms only. So because of finally we have to get the result by multiplying this integration with this differentiation with this integration term, that is the first term. Now the second differentiation term and the second integration term multiplied each other, that is our new term. So and this fourth term, suppose the fourth term is 0 and the fourth term of the integration, 0 into integration is 0. That's why this process is continued to number of terms and the number of terms is equal to the differentiation terms. Now let us see the examples regarding this method. We can get the more clarity. Now see the first problem of this method, that is integral x square sine 2x dx. By observing this integration, so this is suitable for our method 4. Here x power n, that is the n is equal to 2, and f of x, in the place of f of x, here it is the sine 2x. So first of all we have to performing the differentiation operation for the x power n. So the first term is right as usual, that is x square. So now we can performing the differentiation operation for this first term. So differentiation of x square is the 2x. So x power n into x power n minus 1. So again we have to get the third term by differentiating the second term. So differentiation of 2x is equal to 2. So differentiation of 2 is equal to constant, so that is equal to 0. Now we have to do the integration for the f of x term. So integration of sine 2x. So integration of sine 2x is the minus cos 2x by 2. Right? Now we have to get the second term of the integration by integrating this first term. So right, minus as usual, integration of cos 2x, that is the sine 2x. So sine 2x by 2, here already we are having the 2 into 2, that is equal to 4. Now again we have to do the integration for this second term. So integration of sine 2x is the minus cos 2x by 2. Already here it is the minus into minus plus, that is cos 2x by 2 into 4, that is 8. Now we have to do the again integration for this third term. We get the fourth term, but the fourth term is not useful because of already here we are having the four terms, that is the first term, second term, third term, fourth term. Here the fourth term becomes 0. Fourth term here it is the 0. So 0 into the new term of this fourth term integration is also becomes 0. So no need to evaluate the integration of the fourth term. So just to get the result of this integration, just by multiplying the each differentiation term with the integration terms. And one more thing here, it is the signs are important. So to apply this operation, the signs of the first term is plus, minus, and so on. It will be continued. So here the first term of this differentiation is x square, and the first term of the integration is minus cos 2x by 2. Finally the result is, the answer is x square into minus cos 2x by 2 plus, so here it is the minus, so minus into minus, that becomes plus. So differentiation of 2x, so the differentiation term is 2x into, so sin 2x by 4. Of course these are cancelled by 2, so we can simplify the in further. So again here it is the plus term, so 2 into cos 2x by 8, 2 cos 2x by 8. So here it is the 0 into our new term integration is also becomes 0, that's why I am neglecting. So this is the, so 4 times cancel each other. So this is our the final result of this problem. So remember one thing, so we are performing the differentiation and integration individually, separately. So we are performing the differentiation for the x power n term, we are performing the integration for the f of x term. So finally we can multiply the differentiation with the integration terms. And remembering the signs are arranged in a plus minus and so on order. Now see the another problem regarding this method. The second problem is integral e power x into x to the power of 4 dx. This is the second problem. So by observing that this integration, here it is the x power n and it is the f of x function. Both are product each other, multiplied each other. So here x power n is equal to x to the power of 4, f of x is equal to exponential function, that is e power x. So do the differentiation for the x power n term. So differentiation, write x power 4 as it is in the first term. Now performing the differentiation for the from the second term onwards. So differentiation of 4 x to the power of 4 is 4x cube. Differentiation of 4x cube is 12x square. Differentiation of 12x square is the 24x. Differentiation of 24x is the 24. Differentiation of 24 is the 0. So now do the integration for the f of x function. So integration of e power x is our first term, that is e power x. So the second term is the integration of the first term, that is also e power x, e power x, e power x, e power x. So no need to write here because here it is the 0. Of course you can write also e power x. So the symbols or signs are plus, minus, plus, minus, plus and minus. So the result of the problem is simply multiplying the first differentiation term with the first integration term. So x to the power of 4 into e power x plus, so here it is the minus, so that's why it becomes minus 4x cube e power x plus 12x square e power x plus 24x into e power x plus 24 into e power x. So taking common e power x, so x to the power of 4 minus 4x cube plus 12x square plus 24x plus 24. This is our final result. Is it easy? So now do the another problem. So that is third problem is integral x cos 3x dx. So do this problem at your home and mention the answer in the comment box. Now see the another method, that is method 5. Suppose the integral 1 by ax square plus bx plus c dx. So the given problem is in the form, that is integral 1 by ax square plus bx plus c. So we know that ax square plus bx plus c, the equation is the quadratic equation. Suppose the given problem is in the form, so we have, first of all we have to check the condition to solve this problem. That condition is 4ac minus b square. 4ac minus b square. So we know that here a, b, c values are the constants. So before doing this problem, we have to check the condition, that is 4ac minus b square. Suppose 4ac minus b square is greater than 0. So the result of this problem is 2 by square root of 4ac minus b square tan inverse ax square plus bx plus c by square root of 4ac minus b square plus c. So this is the result for this integration if the 4ac minus b square is greater than 0. Otherwise this is not suitable. So not only this problem, each and every problem, so after completion of the integration we have to make, that is plus, we have to include the plus c. Plus c means constant here. So definitely we have to include plus c after the result. Suppose 4ac minus b square is less than 0. Then the new formula for this problem is 1 by square root of 4ac minus b square, which is in modulus log lower factor by higher factor. Plus c. So here lower factor means so we have to ax square plus bx plus c is in the quadratic form. So we have to make the factors for this equation. So here the order is 2, that's why the factors are 2 factors. So the lower factor is written in the numerator and the higher factor is written in the denominator. So this is the result for this problem whenever 4ac minus b square is less than 0. So let's see the problems regarding this concept. Now see the first problem of this concept, that is integral 1 by x square plus 4x plus 5 dx is equal to. So observe the integration. Here it is, the denominator is in the form of quadratic form, that is ax square plus bx plus c. So first of all we have to check the condition is 4ac minus b square. If it is greater than 0, that is in the result of this integration is different. If it is less than 0, the result of the integration is different. So let us check 4ac minus b square. Here it is, the a value is 1, b is the 4, c is the 5. So 4ac means 4 into 1, 5 minus b square. So that is 16. So 4. Here the result is 4. 4 is greater than 0. So whenever the result is greater than 0, the formula for this integration is 2 by square root of 4ac minus b square tan inverse differentiation of ax square plus bx plus c d by dx by square root of 4ac minus b square plus c. So substitute the values in this equation, that is the result is 2 by, so 4ac minus b square result is 4. So root 4 is equal to 2 tan inverse differentiation of ax square plus bx plus c. So differentiation of x square is the 2x and differentiation of 4x is the 4. Differentiation of 5 is the 0 by square root of 4ac minus b square, that is square root of 4 is the 2 plus c. So here it is the cancel. Here this is the 2 times cancel. Finally the result is tan inverse x plus 2 plus c. This is the result of the first problem. Now check the second question. So here it is also the quadratic equation form, ax square plus bx plus c. Now let us check 4ac minus b square. So the 4ac minus b square is the 4 into 5 minus 36, that is 100 minus 36 64 greater than 0. So the same formula is applicable for this second problem also. Now let us see the result of the second problem is 2 by square root of 4ac minus b square. So 4ac minus b square result is 64. So square root of 64 tan inverse d by dx of ax square plus bx plus c. So d by dx of 5x square is the 10x plus d by dx of 6x is the 6 and d by dx of 5 is the 0 by square root of 64 plus c. So that implies, so 2 by square root of 64 is the 8 tan inverse 10x plus 6 by 8. So this is the result for the second question. Now see some more examples regarding the method 5. Now see the another problem, that is integral 1 by 3 plus 2x minus x square dx. So here it is the denominator is in the form of quadratic equation, that is ax square plus bx plus c. So let us check the condition, that is 4ac minus b square. So 4, here a value is the -1 and c is the 3 minus b square. So that is 2 square is the 4. So minus 12, that is minus 4, that is minus 16. So obviously less than 0. Minus 16 is less than 0. So whenever this condition is 4ac minus b square is less than 0, the result of the integration is 1 by square root of modulus of 4ac minus b square log lower factor by higher factor. Now we have to find the factors for this quadratic equation. So taking common minus from the quadratic equation, that is x square minus 2x minus 3. So that is equal to, so factors of this x square minus 2x minus 3, that is x minus 1 and x plus 3. So we can easily get the factors by using the formula also, that is square root of b square minus 4ac by 2a. So now this is the one of the factor. Finally, so the x is equal to 1 and x is equal to minus 3. So multiplying with the minus. So the result of this integration finally becomes so 1 by square root of 4ac minus b square. The 4ac minus b square value is 16. So modulus of 16 minus 16 is the 16. So square root of 16. So square root of minus 16. That is becomes the 4 log. So the factor is x plus 1 by x minus 3 plus c. So this is the result of the third problem. Now see the another problem, that is integral 1 by square 4x square plus 12x plus 5 dx. So let us check the condition. Before doing this problem, we can check the condition. If whether it is the greater than 0 or less than 0. So 4 ac a into c minus b square, that is 144. So that is equal to minus 64. This is less than 0. So the same formula is applicable for this problem also, that is 1 by, so square root of modulus of 4ac minus b square. 4ac minus b square result is the minus 64. So modulus of minus 64 logarithmic of, so factors, the factor of the 4x square plus 12x plus 5. So let us find the factors. So by using the formula, simply by using the formula, that is square root of b square minus 4ac by 2a. So this is the formula for finding the factors for this quadratic equation. So the factors of the quadratic equation is x plus 1 by 2 and the another factor is 5 by 2. So the factors are 1 by 2 and 5 by 2. So just simply substitute in the factors in the above logarithmic term. So finally we get the result like this. Now see the another method regarding the integration concept, that is the method 6. Let us see. In this method, we are going to solve the integration is in the form of partial fractions. So directly go to the example. I can explain in the example. So integral 2x minus 1 by x minus 1 into x plus 2 into x minus 3 dx. Here the denominator sorry, this is the integration is in the form of partial fractions. So no need to find the partial fractions and no need to apply the integration for this problem. Directly we get the result by knowing the shortcut technique, method 6. So let us see. So here the denominator having the linear factors. The linear factors are, the first one is the x is equal to 1. Second one is the x is equal to minus 2. That means this term is to be equal to 0. So the third term is to be equal to 0. That is x minus 3 is equal to 0. Finally x is equal to plus 3. So these are the three different values. That is 1, minus 2 and 3 of the x. So here these values are substituted in this integration term. So finally, first of all, the first term is the x is equal to 1. Substitute x is equal to 1 in this integration term. So 2 into 1 minus 1 by, so no need to substitute the x is equal to 1 in the x minus 1 term, because of this is coming from this factor. So skip this factor and substitute the x is equal to 1 in the other two factors, that is 1 plus 2 and 1 minus 3 into ln modulus of x minus 1. Write the factor in the ln term. So this is our first substitution of the x is equal to 1. Now substitute the x is equal to minus 2 in this integration. So finally it becomes 2 into minus 2 minus 1 by, so substitute minus 2. So minus 2 minus 1. So skip this factor, because of so this x is equal to minus 2 is coming from this factor. So and write the x minus 3, substitute the x is equal to minus 2 in the another factor, that is x minus 3. So minus 2 minus 3. Now write this factor x plus 2 in the logarithmic ln term, that is ln x plus 2 plus. Now substitute the x is equal to 3 in the same scenario. So that is 2 into 3 minus 1 by, so substitute the 3 value in the factors. So 3 minus 1 and 3 plus 2. So skip this factor, because of it is coming from the x minus 3. So and write ln this factor into ln term, that is ln x minus 3 plus c. So this is our final result. So no need to apply the integration. So directly we get the result of this integration. This is, so by simplifying this values, we get the answer of the integration is minus 1 by 6 ln x minus 1 minus 1 by 3 ln x plus 2 plus 1 by 2 ln x minus 3 plus c. So this is the result of the partial factors of the integration. Now see another problem regarding this method. So integration x square plus 4 by 3x cube plus 4x square minus 4x dx. So first of all, we have to get the factors from the denominator. So the factors, to get the linear factors, let us take common of the x from the denominator. So taking common x, then 3x square plus 4x minus 4. So this is equal to dx. So again, this 3x square plus 4x minus 4, this is in the form of quadratic equation, ax square plus bx plus c. Now we have to get the factors from this quadratic equation. The factors are, the number of factors of the quadratic equation is 2 factors. Now let us find the factors. X square plus 4 x into, so the factors of the quadratic equation is x plus 2 into 3x minus 2 dx. Now we have to take the x values. X is the first value of the x is 0 and the second value of the x is x plus 2 is equal to 0. So the factor is to be equal to 0, then x is equal to minus 2, and the third value of the x becomes 3 by 2. Substitute the x is equal to 0, x is equal to minus 2, x is equal to 3 by 2 in this integration term. So finally, so x is x in the place of x substitute as a 0. So 0 square plus 4 by 3 into 0 cube. So sorry, here no need to substitute. Oh sorry, here we have to substitute it. So x is equal to 0, value is coming from the x. So skip this factor. Finally, the remaining two factors are 0 plus 2 and 3 into 0 minus 2 ln modulus ln x plus. So now substitute minus 2 in the this x values. So minus 2 whole square plus 4 by minus 2 into, so skip this factor because of it is coming from this factor, minus 2 into 3 minus 2 minus 2 ln, the factor is written in the ln term, that is x plus 2, right? Now the last one is the x is equal to 3 by 2, substitute in the integration. So 3 by 2 whole square plus 4 by 3 by 2 into, so skip this factor and write this factor. So 3 by 2 plus 2 ln 3x minus 2 plus c. So by simplifying this equation we get the final result. So the result is here, it is the 0. So these are cancelled. So finally ln x plus, so here it is the value of this term is plus 1 by 2 ln x plus 2 plus, and the value of this term is 5 by 2 ln 3x minus 2 plus c, and this is the result of this problem. So friends, so meet you soon in further topics of the integration shortcut methods. Thank you everyone.